Hi, we have the AP Physics 1 past paper 2017. We are discussing free response question section. The question 1 carry the 7 points. In the statement, in 3 circuits as shown in the figure, the batteries are identical and the light bulbs are identical, means all have the same resistance. In a circuit 1, a single bulb is connected to the battery like this. Then in circuit 2 and 3, two bulbs are connected battery in different phase. Like this is a series path, this is a parallel combination. The light bulbs labeled ADE as shown in a figure rank the magnitude of potential difference across the bulb ABCDE from largest to smallest. If the light bulb have the same potential difference across, then state that explicitly. Okay, first of all, we discuss all bulbs step by step. For let's see, bulb A, we have bulb only one bulb in a circuit A. The potential difference across bulb A is equal to the battery voltage. Whole battery voltage is applied to the bulb A. Okay. From B and C, a series pair battery is shared between the two identical resistance. Resistance mean bulb. Then up in series, each get half of the battery voltage. Mean when the energy start moving, some energy is used here, remaining energy is used here, then it go return. So both energy is shared between the two identical resistors. Half of used by B and half is used by C. Okay. So battery each bulb get half of the battery voltage. Bulb D and E, this is the parallel combination. Across the battery is connected directly from the uh, direct connection from each bulb. So voltage across each is same equal to the battery voltage. VDE is equal to V. Hence, from according to the question, ranking from largest to smaller, VA, VD, VE, they are getting equal to battery voltage equal to V, that is greater than the voltage potential difference getting by B and C. That's the greater value, that is the half. So we come to know the ranking VA, VD, VE have the more potential difference as compared to VB and VC. Okay. Explain how you determine your ranking. Bulb ADE has the largest potential difference because they are connected directly across the terminal of the battery as shown in a circuit 1 and 3 we have seen previously, meaning entire battery voltage is applied to them. But B and C have smaller potential difference because they are connected in series as we have seen circuit 2. The total voltage is shared between two equally identical bulbs resulting half voltage each will get. Now, next part of the question is the battery R starts an identical amount of unusable energy and R are connected to the light bulb in the circuit at same time. Okay. In which circuit the battery run out of usable first? In which circuit battery run out of unusable or large? In clear, coherent paragraph length response that may be contain equation and drawing explain your reason. Okay. First of all, we have to clear some concept. All batteries start with same amount of energy. That's the given. Battery depletes its energy by delivering power to the circuit. When we say higher total drawn, it's mean energy is using faster. Okay. Now we have the equation P is equal to V square by R. The R equivalent is the equivalent resistance, mean higher the equivalent resistance and then power drawn will be low. Vice versa, if we can say if the equivalent resistance is small, then power drawn will be larger. That's the vice versa solution here. Okay. We have the 3 circuit. Each of them we know in circuit 1 there is only one bulb, so only one resistance is there. So we R equivalent is equal to R. So P1 is equal to V square by R. That's the P1 power drawn from the circuit 1. From circuit 2, B and C are in series. Series total resistance is the equivalent sum, algebraic sum. So R plus R is equal to the 2R. Simple algebraic sum in series total resistance. So net equivalent for the equivalent value we have placed R2R, that is the half of the P1. If we let this is the P1. So P1 by 2. And in circuit 3, when D and E are parallel, in parallel combination, we do the reciprocal sum of the resistance. So 1 over R equivalent is equal to the 2 by R equivalent will be R by 2. When we place this in the power formula, we will get this is indicating the P1. So that's the 2P1. So we have the now clear cut combination. P3 has 2P1, that is P1, that is P1 half. So we can say power drawn in a circuit 3 is greater as compared to circuit 1 and the minimum from circuit 2. Thus, battery deliver most power in a circuit 3 because the lower equivalent resistance from the parallel and run it fast. Okay. Circuit 2 battery deliver the least power because the lowest current due to higher equivalent resistance from the series so last the longest. So that's the answer. If you have any queries, kindly ask in the comments. Okay. Take care.